Hi, this is Kamran. The purpose of this paper is to replicate Greenwald's paper for figures 3A, B, C, and D, which is a zero-sum soccer game. The game is played between two players, player A and B. Each player can take the possession of the ball and do a goal. If the player is successful, he receives a reward of plus 100 and the opposing player receives a reward of negative 100. If the player takes the ball into the opponent's goal, then it receives a reward of negative 100 and the opposing player receives plus 100. Each player can steal from each other, and the player movements are restricted to east, west, north, or south, and stay. For the purpose of experiments, I did simulations run for 100,000 iterations of these games, and I passed them through correlated queue, faux queue, friend queue, and queue learning algorithms. The results of the error versus the iteration were recorded, and the learning rate, gamma, and default Q were fixed at 0.01, 0.9, and 1.0. The first experiment was very similar to the one that I see in the paper for correlated Q learning. The convergence seemed to happen at around 50,000 iteration. However, the amplitudes before 30,000 iterations seemed very different from that in the paper. The second experiment is also similar in the sense that the convergence is happening at 50,000 iteration. However, the amplitudes are slightly different. In the paper, the faux Q and the correlated Q were supposed to be very similar. However, my results are very different. The third experiment is actually a very close copy of the one in the paper. The iterations were converging. The convergence was happening at 5,000 iteration. The fourth experiment for Q learning was similar in the sense that the convergence was not happening, and however the amplitudes and the tapering is very different in the paper than in mine. So some of the reasons why these changes may be happening between my results and the paper are because of the state space. I assume the state space to be 2x4 grid. However, it's not conclusive that that's the case. The learning rate in the paper was set to be 0.0001. However, I noticed that was causing all kinds of errors, and so I figured that 0.01 was actually a much better value. Choosing the right value functions and other defaults made a huge difference in how quickly things were converging and working. Linear programming and which linear program to choose was also one of the serious considerations. So in conclusion, if their values are missing, then it is not easy to replicate research. That's all I had. Hope you like the presentation. Thank you.